and welcome to our next video on statistics. And in this question, we'll learn about standard deviation and about the coding. It's quite a long video, so there are 4 parts. In the first part, we will learn about what the standard deviation is, and then we will learn how to calculate standard deviation using a calculator and how to do it using formulas from the formula book. And finally, at the end, we will look at how to deal with questions where they used some coding. So what is standard deviation? So a deviation D is the difference between each data value in the data and the mean. So as you can see here, it's data value take away the mean. And the best way how to understand what actually a standard deviation is by looking at an example. So we have recorded 5 temperatures in 5 consecutive days in degrees of Celsius. They are here. And if we calculate the mean temperature, we get 20 degrees. And the deviations are 17 take away 20 is minus 3, 19 take away 20 is minus 1, and so on. So we will get these 5 deviations. When we calculate the average deviation, we get 0 because, as you can see, all the positive and negative deviations, they cancel each other. So in order not to lose the information about the spread of the data, the trick is that we will first square all these deviations, and then we calculate the average of the squares, and then we square root the answer. And this number is called the standard deviation. So for our temperature data, we will get, just again, adding the squares, dividing by 5 and square rooting them, we get 2. So the standard deviation of these 5 temperatures is 2 degrees Celsius, and the mean was 20. So standard deviation tells us about how much are the data spread around the mean value, and you can think about it as a positive average deviation. And the last thing you need to remember is that for calculations, it's much faster to use a different version of this formula, which is in the formula book, and it's here. And the expression inside of the square root has got a name, and it's called a variance sigma squared. So let's have a look at 2 examples. So this is an example where we've got a discrete data. So the axes are at the top row and the frequencies of each wind speed are at the bottom row. And we will learn how to calculate the mean and the standard deviation for these data on the calculator. So let's input the data into calculator, pressing home, statistics. Okay, 1 variable, and let's first input. And so the axes are at the top row and the frequencies are at the bottom row. So inputting the data, 6, okay, 7, 8, 9, 11, 12, 13, 14, and 16. And now doing the frequencies, starting from 2, 3, 2, 2, 3, 1, 2, 1, and 2. We got all the 10 data, and we just press OK now, and OK again. And just to zoom in, we can see that the mean of the data is 10.2, and the standard deviation sigma x is 3.17, correct to 2 significant figures. Okay, so now we can put the results here on this slide. So the mean was 10.2 and standard deviation was 3.17. And when we've got a continuous data, like for example in this example, this is the rainfall, which is summarized in this table in the middle of this slide. So we first have to calculate the midpoint of every class. But usually when you start doing exam questions, you are given the midpoint of every class. So usually you don't really have to calculate it because you are given the midpoints. And again, we will use the calculator, and we will calculate an estimate for the mean and for the standard deviation of these data, because we don't know exactly what the rainfall was. Then therefore we can only calculate an estimate. We cannot calculate the real mean. So again, let's do the calculations on the calculator. So let's first enter the data into calculator, statistics, okay, and okay again. So the x's are in the second column and the frequencies are in the first column. Let's first enter the x's, 0.25, 0.75, 3, 7.5, and 20. And now the frequencies. The frequencies were 121, 10, 24, 12, and 17. Okay, so let's see the results. Okay. Zooming in, we can see that the mean of the rainfall was 2.93 and the standard deviation was 5.77, so 3 significant figures. And so we can bring our result from the calculator in here. So the mean for these data was 2.93 and the standard deviation was 5.77 millimeters. When we are given the sum of data and the sum of x squared, then instead of using the calculator, we can use those two formulas in the formula book. And in exam questions, they expect you to be able to use them. So the first formula, which is in the formula book, is used when each data is there only once. And formula 2 is used when we are given the data in a frequency table. So let's first look at one example, how to use formula 1. So there are heights of 5 students, and we are given that the sum of the data is 864, and the sum of the squares of those heights is this number here. And we need to find the mean and the standard deviation of students' heights. So for the mean, again, we just use the sum of all the data, divide by 5, and so we can see that the mean height is 172.8. And for the standard deviation, we use formula 1, because each data is there only once, each data value, plugging it into the formula, using sum of x squared, which we substitute here, dividing by 5, taking away the square of the mean, and we get the standard deviation as 3.31. Let's now look at one example, how to use the second formula. So when the data are given in a frequency table, we can see that each data, for example, this 2.75 is there 8 times, 3.75 32 times, and so on. This formula is not in the formula book, so you have to be able to derive it, but it's very similar to formula 1. You just multiply each number, each squared number, by its frequency. So again, we are given these sums of data and sums of squares of data. So to calculate the mean, we just substitute this number here into the formula for the mean, divide by 160. We can see that the mean weight of the fish is 4.325, and using this value here, we substitute into the formula for the standard deviation. And be careful when you substitute mean, don't round it up. You have to substitute as many decimal points as you can. So in this case, we have got 3 decimal numbers, or if it's a fraction, substitute the whole fraction, don't round it up. And then the answer for the mean weight of fish is 0.613. And finally, let's have a look how to use coding. So when the data are coded, you have to remember two things. The first important point is that whenever that the mean of the coded data is affected by both, by all operations. If you are plussing some numbers, subtracting, multiplying, or dividing, all these operations will have impact on the mean. So for this coding here, both taking away C and dividing by N will change the mean of the coded data. On the other side, the standard deviation is only impacted by multiplying or dividing by some numbers. So adding or subtracting have no impact on the standard deviation. So in this case, taking away C will have no effect on the coded standard deviation, and the only effect will be when we're dividing by N. So we've got 5 coded temperatures. So let's first find the mean and standard deviation for the coded data. These 5 coded data, 6. So you can just use your calculator and you will get the mean as 1.42 and standard deviation is 0.564. And now when we are given the formula that they used, so the data was coding using this formula here, x minus 100 over 10, we might be asked to find the mean and the standard deviation of the original temperatures, which we don't know because we were only given the coded data. So now we can use those formulas from the top of this page, substituting for C and N 110. And now to get the mean of the original data, we have to make here the mean of X the subject, which will give us this equation here. And when we substitute the numbers from part A, we get the mean of the original temperatures as 114.2. And in the same way, when we make standard deviation of X subject in this formula, we get this equation here. And again, substituting the numbers from part A, we get the standard deviation of X is the original temperatures as 5.64 degrees Celsius. This is the end of the video. Thank you for watching.